Hey guys, today we are going to solve the problem longest palindromic substring. In this problem, we are given a string S and we are asked to return the longest palindromic substring in S. So in order to solve this problem, obviously first we have to understand what is a palindromic string. A palindromic string is a string where it doesn't matter if we read the letters from left to right or from right to left, we are going to get the same letters in the same order. So, for example, ABA is a palindromic string. In contrast, AB is not a palindromic string because when we read it from left to right, we get the letters A and B in that order. But when we read it from right to left, we get the letters B and A, which is not the same. So this is not a palindromic string. Now that we understand what is a palindromic string, how can we solve this question? Well, one option would be to simply iterate over all possible substrings. Okay, we're going to check all possible substrings, and we're going to ask, is this substring palindromic? How much would that cost us? There are n squared possible palindromic substrings. And to check if a string is palindromic, we obviously have to iterate through all of the string. So that costs us linear time. A total of O of n to the power of 3. Sorry about my writing. So now that we know that we can solve this problem this way, let's think, can we do any better? Well, there is a trick. And the trick lies in the fact that there are two ways that we can check if a string is a palindrome. One way is, given a string, we are going to initialize pointers to the left and to the right of the string. And each time we will ask, do the letters match? If they don't, then obviously this string is not palindromic because we want it to read the same from left to right and from right to left. And if they do match, then we keep expanding inwards. Then right index will shrink by 1 and left index will grow by 1. And again, we will ask, do they point to the same letters? And if yes, everything is good. If not, we return that this is not a palindromic string. This is one way. But there is one more way to check if a string is palindromic. Let's look, for example, at this string. Again, we could initialize pointers to the left and to the right and do the same process and it would work and everything is good, but there is one more option. We could start from each center and expand. So we would start both indexes to point to the center. We ask, do they match? If they do, then we are going to expand this time outwards. Again, we are going to ask, do the letters match? If yes, expand. If not, this is not a palindromic string. So this is the other way we can check if a string is palindromic. How can we use this way to solve the original question more efficiently? Well, we could try to expand from each center of the original string and keep expanding as long as the string is palindromic. So if we look at the original example, we had B, A, B, A, D. For example, for each center, for example, for this B in the middle, we could start expanding, and as long as the left and right indices point to the same letter, then that means that we are looking at a substring that is palindromic. And again, now right will be here and left will be here. These are the same, so this is still palindromic. So we move right and left indices. And now they are not equal, so this is no longer a palindrome, and doesn't matter what comes here, it will never be a palindrome. So this is the other way to solve, to answer the question, is a string palindromic? How can we use that to solve the original question? Well, this time there are only n possible centers to expand from, and each expansion will cost us at most n time or linear time. So that would total in a total of O of n squared, which is significantly better than the previous solution. Now let's move on to the code. Okay, so the first thing we are going to do is we are going to write the function that will help us to expand from each center. This function will receive two indices and not one, and soon I will explain why. And it's simply going to check or simply going to loop while we still are looking on a palindrome, keep expanding, and when we are not looking on a palindrome, then return the length of the biggest palindrome. Or not the length, maybe it's better to return the indices or the boundaries of the palindrome. Okay, now we have to remember that we want to move the indices. Okay, good. And the next thing we are going to do is we are going to initialize a maximum value for the length of the palindromic substring, the biggest one we've seen so far. And we are going to iterate over all of the possibilities for a center. So this is just going to be something like this. For I in range of the length of the string, we are going to get the length of the palindrome that starts with this index. So this is its length. And if it's bigger than the previous maximum, we are going to update the maximum and we are going to keep the indices. And at the end, we want to return okay. So there is one problem with this code, and that is a palindrome can have two centers. What do I mean by that? If a palindrome is of odd length, then it will have only a single letter as its center. But what about, notice how we keep increasing by 2 each time. So we are checking palindromes of length 1, and then we are checking palindromes of length 3, and then we will check palindromes of length 5, right? So we start with 1, 3, and 5. So we are checking all of the odd length palindromes. But what about palindromes that are of even length? For example, here we could take B and B. This is a palindrome. So we also have to expand where we have where we initialize our center to those two indices, and then it will be palindromes of length 2, palindromes of length 4, palindromes of length 6, and so on. So we just have to add here. So this was odd length palindromes. Now we are going to check for even length palindromes. So it's going to be pretty much the same, which tells me that you could put that in a function, but we are not going to. I hope I make no mistakes with the code, but we will run it in the end to check that everything is working correctly. And again, we're going to check if the length is bigger than the current maximum. We are updating the maximum, and we are keeping the indices. So I'm pretty sure this should work. And if not, then I'm going to quit. Okay, it does. And now we can submit the code. And as we can see, it's pretty efficient. And I hope this video helped you guys.